are actually sponsored by VT Africa Holdings, the Department of Education, as well as other sponsors. We are having smart caps, which will be our approach to allow you to go online and check our sessions and interact with the material that we are actually giving out. And for that, last time we were looking at the topic of polynomials. So today, I would want to give you sort of a quick rundown of the topic in case you missed something, if our audio was a bit of shaky. But I believe that you'll be able to pick everything from the start. But we'll just go through it very quickly. Then we want to measure more on the factor theorem, the remainder theorem. We want to look at a few other techniques that you can use on a polynomial. So for our assessments, you can actually go to hellosmart.com, and at hellosmart.com you will be asked to sign up as a guest, and then you put your ID number, which is 598751. So you put your name there and you are already in the game. You can actually show us how smart you are as you interact with all this session. So I will flash this number again later on when we are actually going into some assessment. But for now, let's look into some bare basics of polynomials. Okay, so this is a topic that is in your term 2. If you're following the syllabus arrangement, your ATP, you see that you started looking at algebra is from grade 6 and so forth, but at this stage you are now dealing with polynomial, which means you are at an advanced stage. You are dealing with many terms grouped together into a polynomial. Okay, so in terms of what we came out to cover, we want to look at all these areas which have to do with your long division, your formative assessment of factor theorem and remainder theorem, as mentioned before. So let's see how we can factorize a polynomial. So this is our general polynomial. It looks a matter of having your a, then x to the power n plus another term, which will be a constant, then x to the power n minus 1, and so forth. What is happening here is simply that it's an expression with two or more terms consisting of variables of differing degrees and coefficients and constants. As you shall see many examples that we have, you will have a chance to actually understand more about polynomials. But what do we mean when it comes to factorizing a polynomial? It is simply to write a polynomial as a product of its factors. And we began to mention that there are several ways of actually factorizing a polynomial. You can group in pairs, you can take out a common factor, you can use substitution, you can use the difference of two squares, you can complete the square, you can also use the quadratic formula. So this, along with your factor theorem, that can help you to solve a polynomial, to factorize it. So how many action steps can we take? So we have different options here. We can use the grouping. So it's 1, 2, 3, 4, 5, 6. So far, I've mentioned 6 steps you can use to factorize a polynomial. Now, here is a polynomial which we can just do one of these to say, if we are factorizing that, we look for the common factor here and there, which happens to be x, then we are left with x minus 3. That is your factorization in complete form. So this, if I may put a line here, just to show you the correct questions, you will notice that sometimes if you are able to use your multiplication tables very well, you can actually relate to this from two brackets. So you have your x for the first term, and then for the last term, you have to choose a number that is going to give you 35 when you multiply. So which is only 5 times 7 or 7 times 5. Now that there's a plus and a minus or a minus and a plus, you put minuses on both. So this would be how you could factorize this. And you do the same with any other question similarly. So if I am to look at this one, I can see that the first term is a 2x squared. So I need to have a product of 2x squared from these two that I've put so far. And the last product is a 3. 3 can only come from multiplying 1 times 3 or 3 times 1. So you have to make your choice in terms of the middle term. So 1, 3 plus plus, because we have a plus and a plus. That would be your factorization. The main thing to just check is to check your middle terms and your first and last terms. They must add up to the middle term. So the middle term must come from adding these. So in this case, you have 2x times 3, which gives you 6, then plus 1x in the middle, which gives you 7x. Everything else is coming together. Okay. So there are our solutions as discussed just now. Sometimes you have an equation that you have to solve. So if it's an equation, it's not any different except that you now have a solution at the end of a particular value of x or y or whatever the case. So in this case, remember we factorize this to this. So this time we say equals to 0. And to get that solution, we now say x is equals to 0 or x minus 3 equals to 0, which gives us x equals to 3. So this and that are our solution from factorizing. We also say that when you factorize, you don't need to, sometimes you might not need to use brackets. Like in this case, you could just choose to say, okay, let me put square root on both sides. So you put a square root on both sides, and square root of 4 would give you 2. But that's what most of the learners do. They forget that a square root actually gives us 2 results. We have a minus and a plus. So you must be careful to remember that part. This represents the plus or minus. So you can have a plus 2 or a minus 2 rather. So that would be your 2 solutions to the problem. Of course, you could put them on one side and factorize as well. You will get the same answer. Okay. And when it comes to the last one there, let's say it's equals to 0. So to solve that, you'd say x there. Then so you've taken care of the x squared. But the only way you can multiply two numbers and get 1 is when you multiply 1 times 1, if they are whole numbers. So if you do that, you see that here we have a problem with the middle term, which is the term you must always check. The middle term is not going to come out as 3x because it will be 1x plus 1, which will be 2x. 2x is not the same as 3x, so it means we don't have to use this method. We must employ another method. So the other method that we mentioned is that you can actually use your quadratic formula, where you simply say x equals to minus. So we put our b. You remember the quadratic formula. You put your b there, which is 3 plus or minus b squared, which is 3 squared, minus 4, a, which is 1, c, which is 1, all over 2a, which is that. So you could just simplify this, but this is your solution. So to simplify it, you have minus 3 plus or minus because of the square root. Then in the square root, we actually have 9. We have a 9 minus 4. So that leaves us in a square root 5 or over 2. This is our solution in said form. Said mean that we are dealing with a square root in our solution, which is more accurate than to use a calculator and get a solution. But if you are asked to give your answer to 2 decimal places, for example, then you use your calculator to get a solution. Okay, so far we've used about 4 of those options we are given on polynomials. The one is to do with inspecting and looking for a common factor. And we also started to use our brackets and multiplication to know how to solve, as well as the quadratic formula. Okay. There is our solution for the few questions we've just looked at. If you are on YouTube, you can pause and recheck your answers at this stage. Okay. We will just sort of give a quick rundown of these questions, because if you check our previous session, we actually touched these questions, but I'm giving a revision of these in case you didn't catch the audio properly. So we mentioned that in this question, which of the options is not a polynomial? And in this case, B is not a polynomial, because a polynomial, poly means many terms. But if you check here, we simply have 1x, which is x to the exponent 1. And that's just a linear function, very simple function. it cannot be qualified as a polynomial. Other functions, yes, they might have, you might have your arguments around them, but they at least have many terms of varying degrees of x, such that they can qualify as polynomials. Let's check again on another situation. If you're asked to factorize this, we said that you can simply look and inspect that y is common on both sides, on both terms. So y outside, you remain with that in the bracket, which is your c. So don't say it cannot be factorized. Okay. And when it comes to saying factorize by grouping, in this case, you can group these according to even how they are arranged here. But when you group, in most instances, look for the pair that is a common factor, you put them together, and the other pair that is a common factor, you put them together. So in this case, our pairs are kind of together already. It's the pairs are AB plus A plus B minus 1. So we now factorize these pairs. The first pair, the common factor on the two terms is A. So we remain with B minus 1 plus. On the second pair, the common factor is 1 because there is no letter on A on the 1. So on the minus 1, so we remain with that. Okay, if you notice that we do have the same bracket, so we refactorize it. And so we factor in that bracket, and what remains on the two terms, as it were, A plus 1. So this is the same as that answer. Okay, so B is correct. It's the same thing as option B. Let's already look at another situation where we are asked to factorize this. So to factorize this, you are safer by using brackets than try to use a square root and so forth. Especially, it's not an equation like this. So, but whenever you use a square root, remind yourself that the solution of a square root is either plus or minus. So put the two options. Okay, so here we can say this is a difference of two squares. So automatically we can put two brackets and put our x and x to take care of the x squared, and then 1 and 1 to take care of the 1. If there's a minus in between, that means we have a plus and a minus on the two terms, on the two brackets. That is the same as option C. So it gives us the same solution, C. Okay. How about we try our last method that was listed on the approaches we can use, and this time we want to use the method of completing the square to solve this. So in doing that, you will simply rewrite this, and then from there you say x squared minus 2x plus. There's always a plus on your completing the square method. Then you put half. So this is the main part of your completing the square. You put half of that middle term. So I want to write it in a different color. Half of minus 2 is minus 1 squared. So you squared, and then you continue as if nothing has changed on the expression, but then you are aware that you've put something foreign that you must now remove, which will be minus 1 squared. So if you check, we added minus 1 squared and we removed minus 1 squared. So it means our equation or our expression is still the same. It hasn't changed. Okay, so the moment you are there, you are 80% done. You simply now put a bracket, x, and then you take that minus 1 in my green here, squared, and then the rest of it, you simplify here. You simplify what is happening there. So when you do simplify this part, you see that you have minus 6 minus 1. So your final solution is x minus 1 squared minus 7. So that will be it. And that is your option A. Okay, so that is your completing the square, which is also an important method when you are dealing with functions that have to do with graphs, and you want to look at your turning point and your maximum and minimum. You can also use this sometimes to tell you about those, especially looking at these two numbers. Okay. Let's then venture into another question. So this one starts by saying 0 equals to 3y squared plus 5y minus 12. So again, you can simply use all these different methods we have already learned. You will see that more than 3 methods can give you the same solution. And one of the quickest solutions, if you are good at multiplication tables, is simply to go and put your 2 brackets. But you need to be good at knowing your factors and your numbers well, good enough. So if I do this, I can see that there is 3y squared. So the only way there can be 3y, it means 3y squared can come from this. And then what is the last term? What is the last term there? So the last term which we are seeing there is a 12. So a 12 can come from a 4 times 3. Remember, I can also have 6 times 2, but I'm already considering my middle term, which should come from this. So since there is a mixture of a plus and a minus, I am thinking that since our middle term is plus, it means the bigger part of this red line should be plus, because that's 3 times 3, which will be 9. 9y should be positive. Then the other line inside is minus 4y. If you add these two, you see that they give you the middle term, which is 5y. So that is correct factorization in terms of the question at hand. Okay, now that we have factorized it, we can simply say, therefore, 3y minus 4 equals to 0, which actually gives us what? y equals to 4 over 3, or y plus 3 equals 0, which means y equals to -3. So that saves the day, and we get our solution, which is on A. So I do hope that you are following it, that these methods are employable in solving these questions and making things or life easier, because factorizing is looking at a monster expression and you want to break it into its factors in such a way that you can recognize part of what it's made up of. So I think it's a very good approach in life to factorize your problem, to say what's really the factor that is causing this problem, and you start to look at those problems as entities making the whole. And that way you can start to solve them one by one than to try to solve the whole scenario. Okay, now let's go into that was the solution of the previous. Rather, it's actually another option that we can use, and I'm sure that you can use your quadratic formula in this case. So you can simply write down this one as a question and try to solve it on your own. You simply gonna use your quadratic formula. Just to remind you, the quadratic formula is minus b for your x plus or minus b squared, which is in the square root minus 4ac all over 2a. So use it to your advantage to get a solution. So I'm sure that you have copied down this question and use your quadratic formula to solve for it the same way we have done on the previous questions. Okay. So those people who are using gadgets, again, I remind you that you simply go to hellosmart.com, you sign up as a guest, and you are prompted to enter an ID number. So you put 598751 and your name, and you are already in the mix to show us how smart you can be in mathematics. Okay, so you should be able to see all these questions on your device if you do that. Now, our main work for today is to look at factorizing cubic polynomials. It's very rare that in your grade 12 you go beyond cubic polynomials, even in your graphs as well as in your solving of polynomials. In this case, you simply will be mostly dealing with this, but of course you might want to check here and there if a polynomial is beyond the order of 3, just to see there's not much difference. The same principles work that we are going to be looking at here, but in life the cubic polynomials are sort of the highest representation of what we usually deal with in nature. So that's how a cubic polynomial looks like. It has two inflections. In other words, it has two turning points actually. So the two turning points would be to give you a shape that if it starts down, it ends up like that. So that's your cubic polynomial. But the form of it is this, that it will be, for example, ax cubed plus bx squared plus cx plus d. And this simply represents a polynomial where a, b, c, d are constants, numbers that you can use. You can factorize a polynomial by long division. You can also use synthetic division, and you can also use just inspection. Being clever to notice some pattern within it, you inspect and you find out that that is solvable by whichever method. So a polynomial of the third degree is a cubic polynomial. So here is an example. Use long division to find the quotient and remainder if that is divided by that. So you remember as from grade 5 that you started to do long division. So in this case, you are also doing long division of algebraic expressions. Sounds scary a bit, but very doable in practice. Okay, so there you are going to find some solution here, and you know how you do different things down there. So that's what we mean by long division. Let's check the solution of this particular one. So just to point out a few things, you will see that we concentrate more on this part of the expression that is dividing. So we look more into the x. So x is the one that's going to divide all these terms. So for example, x into the first one will give us x squared. Okay, and you don't leave it there. You then multiply that x squared multiplied by these two. So when you multiply by this, you then get your answer will be that. So you have x squared times x being x squared and x cubed, then x squared times 1 being x squared. You subtract these, then you get another solution. You divide it again by your x, you get your answer. You do the same. So in this case, there is actually a remainder, which is 5. And therefore, we can write our expression in the form that using the factor that we have just used and the remainder. So that shows us how we can simplify an expression even if it has a remainder. Let's give ourselves a chance to do the same on this question. This is a different question, but for now, let's start by looking at another method, which is called the synthetic division. So the synthetic division, for us to find the quotient, we use a sort of a shortcut method where we have that. So again, let's check what was the question. We have x cubed plus 2x squared, x cubed plus 2x squared minus x, and plus 3, which we have down here, plus 3. But we are dividing it by we are dividing it by x plus 1. So remember, we are dividing it by x plus 1. So with the synthetic method, which I find many learners are able to use, if you like it, you want to use sort of a shortcut than the long division, you would look into this and you take the opposite or the inverse of this, which will be minus 1. So you take that minus 1, you put it here. Okay. And then that's the number you're going to multiply with to get this. So generally how it goes, you write your constants. So remember here there is a 1. So that's the 1 here. Then 2, 2, minus 1, 3, 3. From your original mother expression that is being divided. For the one that is dividing, you just take the minus 1. So if this was x plus 2, you would take minus 2. If this was x minus 3, you would take plus 3 to multiply with. So you always take the converse of that in terms of the negative or positive. Okay, having done that, you now say you build this one, you just bring it down. You always just bring down this one to the bottom. But from there on, you now multiply minus 1 times that. That should give you that. So there's sort of a triangular relationship here, cascading from the first to the last. So you get a minus 1. Then you actually add the first term and that on the second line, you get your solution. When you get your solution, again, you multiply that with your minus 1. So your minus 1 is always multiplying what is on the bottom. And then you get that solution. And then from that solution, you subtract. You always add, actually. You add these 2. And then you get your minus 2. Now you have your minus 2. You now multiply again minus 2 with that minus 1. And then you get what? You get your solution. So that solution will be positive 2. Then you add. So you're always adding. You add this and this, you get 5. So what this means is, in terms of your solution, the minus 2 will be the coefficient of this. And then this is your remainder. So if you get 0 there, it means there is no remainder. But if there's a number on that last column, that means that's your remainder. So if you like this method, which is sort of a shortcut way of dealing with it, you can employ it in your solution of, instead of long division, you can use it even for numbers. Okay, so that should do the trick. If you don't understand it, you can rewind this video and try to understand it from the perspective of knowing that the whole thing bangs on making sure that your factor, you simply make x plus 1 equals to 0, which means x will be equals to minus 1. So you take that minus 1, that's the one that's going to multiply everything on the bottom. And then you start by pulling down the first coefficient, and then you start multiplying from there. Okay. A question could come like this. What is the standard form of a cubic polynomial? So how would you go out to solve this situation where you're supposed to choose from these what is the standard form of a cubic polynomial? So those that are using their hand out, your paper, your book, you can actually decide on this. And those who are using devices, I'm sure you should be able to see the questions as they come in your assessment, as long as you are at Hello Smart. So what is the standard form of a cubic polynomial? Okay, so you see that the standard form of a polynomial, you have to make sure that it will follow what proves that it is a third degree. So for a starters, we cannot have this. This is a linear equation because there is only 1 degree on x. So you can actually add these 3 to give you 6x plus 1. That's not a cubic polynomial. Cubic means there must be x cubed somewhere. This also is not having any cube. This is a cube. So it's promising. This, if you check, if you multiply those, we don't necessarily get any cubic. Such, we can get it as a middle term, but we have a situation where we have x squared being the highest term there. So our solution to this would be that B is the solution as we have discussed, because it is a cubed involved and it's in standard form because it's following the sequence of going from your highest power to your constant. Okay. Let's check about our one of our last questions. Use long division to find the quotient and remainder when that is divided by that. So use your long division, which should be something like x minus 2 into x cubed plus 2 rather minus. So let's start it again. X minus 2 into x cubed minus x squared plus 2x minus 3. So when you are solving this, you, again, as we mentioned, to give you some leading on this, you are going to look at this into that. So for example, you get your x squared, and then you multiply that and that, you get x cubed minus 2x squared. Then when you subtract this, you are going to get 0 for this one, and then you are going to get plus 2 just plus x squared on this one. So x squared, because you're actually subtracting, so minus minus will be positive. Then you bring down your plus 2 from this, and then again you might choose not to have this because it's a 0, and then you're again dividing with that x into that, and then you get positive x. So you multiply again, x squared minus 2x. You subtract again, you get 0, you get plus 4. So this was x, so 4x. And again, you don't need the 0, so you might choose not to look into it. And so your main term there is 4x. Then you bring down your 3. And x into 4x will be plus 4. And then you multiply again with that x, you get 4x minus 8. Then your final subtraction will give you 0 on the first, and then 3 minus 8 actually means 8 minus 3, which is 5. So your solution should be what gives you x, so it will be this d, which gives you x squared plus x plus 4 being the quotient, and then the remainder is 5, as we have shown. Grade 12s, I would like to wish you all the best as you do your studies and use all these tools into sharpening your final approach to the exam. And I believe that you are also following up on all these questions as we pose them to you. And on that note, we are going to meet tomorrow again for our session. And just continue to practice your maths, look into all the different aspects and options that we have in solving polynomials. Thank you.